Hey Geometries, this is Mr. Bloom. I'm doing a video on Homework Quiz 10.3 questions. We're having several people asking about them. So let's look at the question one. There's several questions that are of this type. Find the area of the polygon with the information provided. Round your answer to the nearest tenth. So I'm going to round my answer to the nearest tenth here. So I'm rounding my answer to the nearest tenth, and it's a polygon. My area formula for this polygon is this. Hexagon. Okay, a hexagon has 6 sides. So remember, my area formula has A, N, and S. A is my apothem length. Okay, N is the number of sides. Okay, and S is the side length. So A being my apothem length is 12.1. Okay, N, the number of sides is 6. S is 14. Well, when I'm looking at, they asked for the number of sides in my polygon, so we had to know that. And I'm just going to erase that. That should be something that I have, and that is 6. Now I know the number of sides is 6, but remember that's driven from the name hexagon. There are 6 sides in a hexagon. Now I'm going to write my equation, which is area is equal to 1/2 A N S. I'm going to multiply all those values together. My A was 12.1. My N, 6 for hexagon. And my side length is 14. I now bring up my calculator and multiply these things together. So I've got 0.5 times 12.1 times 6 times 14. Now, my answer is 508.2. Okay, so I now see that my answer is 508.2, and that's feet squared, and see if they ask me to round it to the nearest tenth, and it is, so we're good to go. 508.2 should be my answer for this problem, and that's feet squared. Now, sliding on to our next problem. In problem 2 on this test, this example test that I got, I'm asked to find the area of a regular polygon with the given apothem and side length. Round to the nearest tenth if possible. Now, a nonagon has apothem of 50.9 meters. Side measures is 37 meters. Now, keeping in mind, a nonagon is a 9-sided figure. Okay, the area of a nonagon, well, the area, I have been provided all the information I need. I'm using this formula where A is my apothem, and my apothem, the distance from the midpoint of a side to the center of my polygon, they told me was 50.9. Okay, my side length, they tell me here, is 37. Now this is all in meters. And my number of sides, remember, is 9 because it's a nonagon. Well, I organize all this information in my equation. And I put it in my calculator. So once again, we're going to go 0.5, same as a half, times 50.9 times 37 times 9. And it's 8,474.9. And why 0.9? They asked me to round to the nearest hundredth. So 8,474.85, and that is meters per meter squared. And there should be a little squared right here. I apologize for not having that in. That is a me issue. Okay, so we'll make that correction as well. I hope this is making sense so far. Okay, now let's go on to our third question. Now, this one, again, remember, I'm still finding area. Area is 1/2 A N S. There's a bunch of different ways we can do some stuff. Okay, and I'm working on 1/2 ANS, and right here I know as I'm working with a triangle. So and I know the apothem. The apothem is 3.3. My number of sides is 3 because it's a triangle. I must find S. S is going to be found using skills that we used previously in chapter 8. This, if I do this, this is a 30, 60, 90 triangle with the short side 0.3, excuse me, 3.3, and we're going to try to back that up a little bit. Matter of fact, we'll just blow this up. I'm going to blow this part up, and I'm going to show you with here, this part is right here. This is what I'm blowing up. Okay, so this is a 30, this is 60, this is 90. Half an equilateral triangle is 30, so there's 2 of them here. We know this is 3.3. According to our rules, I know if I take the short side and times 2, it's 6.6. If I take the short side times the square root of 3, I get 3.3 the square root of 3. But that is only half of this side. This whole side is 6.6, the square root of 3. Okay? So that's where that information is from. So keep that in mind. I'm just going to move our stuff over here. It'll let me select here. Apparently it won't, so I'm just going to move things over one thing at a time. Oh, let's do it this way. Okay, well, I've got all my information I need. I know my side length is 6.6, so we're going to just erase that so it's out of my way. So this is my work environment, and now I've got A is equal to 1/2 A, which is my apothem, 3.3, times the number of sides, 3, times my side length, 6.6, the square root of 3, and I put that in my calculator. So putting this in my calculator, wherever I hid that, it's right here. I've got 0.5 times 3.3 times 6.6, the square root of 3, times 3. Okay, and that enters to be 56.58, and they ask me to put it into the nearest hundredth, so it's actually 56.59. Now, this is feet squared. There are a couple ways of doing some things. If we go back to my triangle that I had initially, and remember this was 3.3 and this is 6.6 and this was 3.3 the square root of 3. We use the 3.3 the square root of 3 to get that because it's twice of that. But what if I wanted to use this 6.6 with something? Let me get some different colors here. Excuse me. What if I wanted to figure out this 6.6? This is 6.6. This 6.6 is called the radius of my polygon because it goes from the center, because the apothem, and let's point out the apothem here. The apothem, this length here, goes from the midpoint of the side to the center. Well, if I continue from the center to the vertex that we have found, because remember that was 6.6, the center, this polygon radius is 6.6. So I know that this whole height is 9.9, 6.6 plus 3.3. What's that going to do for me? Well, this is another way to look at this answer. Area is 1/2 base length times height. We have found the base, and we can talk about 1/2. My base being 6.6, the square root of 3, and my height being 9.9. Now I can put those in my calculator, and you didn't see any of that. Well, that's kind of a disappointing thing. Let's bring that back. Let's see what you did see. Okay, so you saw that 6.6. Okay, I apologize, folks. I had my head down on a pad. I'm going to erase my setup for my equations. Okay, so I'm going to get there. So we're going to go to the eraser. And remember, what I found, the information I found is still going to be true. We're going to use 6.6, 6.6. We're going to use 6.6 the square root of 3 to help us out, and 3.3. Keeping in mind this whole length, this height now, is 9.9. In my area of a triangle, any triangle will work as base times height. So 1/2 my base length, which is 6.6, the square root of 3, times my height, which we determined is 9.9. I now am going to take these and put in my calculator, and I have 0.5 again, that's the same as 1/2, divided by 6.6, not divided by, I'm not sure why, times 6.6, the square root of 3, times 9.9. And that also returns 56.59. So either way you do it, you still get your answer of 56.59. Okay? And both of them are feet squared. Now let's look at number 4. Now in number 4, I'm just doing angles. And we did this in chapter 7, talking about rotational symmetry. I count up the number of sides, 1, 2, 3, 4, 5, 6, 7, 8, and it'll give me my central angle. So the measure of angle 1 is going to be my central angle, 360 divided by 8, okay, which is 45 degrees. Let's erase that and get a better 45 there. So I've got 45 degrees. Now again, I had 8, and they tell me here, round to the nearest tenth, and I'm fine here, so my first angle is 45 degrees. Now my second one is half of that, because this is coming down here, okay? It's splitting the side in half, and that's my apothem going from the midpoint of the side to the center of my polygon. So 45 divided by 2. And that'll return 22.5 degrees. Now my third one is really about triangles. Now I'm going to erase this stuff so it's clear to see what's going on, what I'm going to be pointing at. I'm going to get a different color here. Okay, so now if I'm looking at this, I've got this angle. That angle is the same in both of those. So I can find it 2 different ways, but the fastest way is to realize that angle 2 is about a right triangle, and angle 3 is the other angle in the triangle. So if I go 90 minus 22.5, that'll return a 67.5 degrees. And why is that significant? Well, it's faster for me to find this measure of angle 3 because it's 67.5 degrees this way. Okay, and remember, I'm using triangle sum theorem. All 3 angles of the triangle add up to 180, but why did I just do 90? Because in a right triangle, that half of my 45 minus 90 would give me the second angle that is acute. Okay, so I hope that will help. In my last question here, I have find the area of each regular polygon. Round your answer to the nearest tenth. Now, this is a regular polygon, and it happens to be an equilateral triangle. Okay, now I am provided the hypotenuse of an equilateral triangle. So if I take 20 and divide it by 2, I get 10. And now the height's 10 the square root of 3 because I'm using 30, 60, 90 triangle shortcuts. Okay, because that's opposite the 60 degrees. This is opposite the 30 degrees. And this is 90. And what does that do for me? Well, this is area is equal to 1/2 base times height. And 1/2 my base, which is 20, times my height, which is now 10 the square root of 3. And I can find the area of that triangle. So let's do that. And I've got 0.5 times 20 times 10 second the square root of 3. Okay, and I hit enter and I get 173.2. And I was supposed to round to the nearest tenth, so it's 173.2. All right, so I'm hoping this stuff is making sense. Again, I'm using stuff that we used before. The 30, 60, 90 rules were very helpful. If you need more assistance with that, you can contact me, or you can just get online at Delta Math and check them out, or you can check them out at Khan Academy. I'm Mr. Bloom, and you're not. Have a great day.